and y, and then x and y are both functions of t. Okay, so really, you have these intermediate variables here, but really z is a function of t in the end. And so to find the derivative of z with respect to t, then you go down all paths. So it's dz dx, or df dx, because z is basically f. So dz df, oh, made a mistake here. This is a partial. I'll have to remember that. I'll have to remember to change that. So that's actually a partial derivative. Dz df, dz dx, and then times dx dt. That's the chain rule, part right there. But then you have to go on all paths and do the same thing. So dz dy, dy dt, like that. Okay, so and then it could be other situations. So here we have where z is a function of x and y, but then x is a function of s and t, and then y is also a function of s and t. So you have that tree like there. So now here we're doing the partial of z with respect to s. So z is a function of x and y, but then each of these are functions of s and t. So really z in the end is actually a function of s and t. So it's the partial derivative here. The partial of z with respect to s would be, you go down all paths to get to s, all paths from z to s, and multiply those. So dz dx times dx ds, and these are both partials now. And then plus dz dy, and then dy ds. And then the partial of z with respect to t, you just go down all paths that go from z all the way down to t, and multiply the results. Okay, so that's the chain rule for this kind of situation that we're in. And these are just a couple of examples of what could happen. But essentially, what you have to do is you have to look at each problem and figure out, what is the main variable, what's the intermediate variables, and what's the completely independent variable down here. Okay, so let's go with the homework. So we have z is equal to sine x cosine y, and then x is the square root of t, y is 4 over t. So here, you would think, okay, z, you have a formula here. Z is a function of x and y, right? And then these two formulas are telling you x and y are each functions of t. And indeed, you're supposed to find dz dt, so dz dt. And according to the first page, it's going to be the partial of z with respect to x. You take all paths down there times dx dt plus the partial of z with respect to y times dy dt. So all paths from z to t and multiplying out, and that's going to give you the answer. Okay, so basically we just have to calculate what these are. So partial of z with respect to x. So here, just look at that right there. And the partial here is going to be, you take the derivative of sine x, which is going to be cosine x, times cosine y. That's that. This one, dx dt. What's this? T to the 1/2. So that's going to be 1/2 t to the minus 1/2. And then this one, dz dt, or dz dy, I'm sorry. That's going to be minus sine x sine y times dy dt. So this is 4t to the minus 1. So the derivative will be negative 4t to the minus 2. Yeah. Okay, now it's not going to like it if you leave the x's in the equation and the x's and the y's, because those are intermediate variables. So they want just like t. So you just substitute things in. So x is the square root of t. So we'll put in, so let me see here. This is going to be, this right here is going to be 2 this times the square root of t. That's that part. Cosine x is the same as cosine of the square root of t. And then cosine y, that's the cosine of 4 over t, like that. And then over here, the minuses cancel. And so we have a 4. And then here, this t goes to the denominator. And we have sine of the square root of t, sine of 4 over t. Okay, so let's put that into Webassign and see if they complain, or if they're fine with it. Whoa, I can't believe I got it right. Okay, so let's look at number 2. So you kind of look at what you have here. So first of all, w is at the top. Then what's the next tier going to be? So here we have z, and we had x's and y, right? So here we have w at the top, and what's the next tier going to consist of?
X and Y.
X, y,
Y and T. Oh, Z.
and z. Z, yeah, x, y, and z. So all 3 of those. Okay, so now x. Okay, and then what's the bottom tier going to be?
T.
Yeah, just t. So just t, because each of these are just a function of t, right? So that's going to be t, t, and t. So that means that this derivative will be what? It will be, so dw dt is going to go from there to all the way under there. So that is what? So it's the partial of w
T.
with respect to x. Yeah, and then dx dt, and then plus what?
dw over dy times by ty over tt
Mm-hmm.
plus dw over tz times by dz over tt.
Yes, exactly. Okay, so what is the derivative of w? Like, we can rewrite this as, let's do this. Let's rewrite this as so this is the square root of all this stuff, right? So you can pull a 1/2 out in front. So that means it's x squared plus y squared plus z squared to the 1/2, and the 1/2 comes out in front. So you really get that. Okay, so what's the derivative of w with respect to t? I mean, with respect to x, I'm sorry.
It's gonna be 2x over all of that. 2x.
Yes.
It's just gonna be x over x squared plus y squared plus z squared.
Exactly. Good. So, and then dx dt will be
4 cosine t.
excellent. And then the next one, dwt, is just going to be y over all that, right?
Mm-hmm.
I mean, dwy. And then dy dt will be
-8 cosine sine t.
yes. And then W dz
Set over all of that.
times dz
T set.
dt.
I forgot the derivative of tangent.
Dang, does anybody remember what it is?
Is that secant squared?
Yeah, secant squared, I believe. Yeah, secant squared. Okay, so, well, let's try to figure something out. Let's see, this thing in the denominator comes up, x squared plus y squared plus z squared. So if we substitute these values in, is there anything that works? So that's 16 sine squared plus 64 cosine squared t plus 25 tangent squared. Ugh. Dang, I don't see how that works. Okay, so maybe the 16, or maybe there's a 16 that comes out, but then you're still going to have what's 64 minus 16? 48? Wait. Yeah, 48, right? So the denominator becomes all that. It looks like, ooh. Oh dear. Okay, and x is 4 sine t, so that's going to be 16 sine t cosine t. So all those is divided by 16 plus 48 cosine squared t plus 25 tangent squared t. Okay, and then so the next one is going to be y is this, so that's minus 64 cosine t sine t, and then z is this one, so that's 25 tangent t, which is sine t over cosine t. So this is going to be cosine cubed. That's weird. Maybe we could just rewrite that as secant cubed instead, like that. Okay, so this looks like that, all that and that combines to give you negative 48. Okay, let's try that. Negative 48 cosine t sine t plus 25 times that. Whoa.
Do we add the denominator as well?
Yeah, all over the denominator. This is really nasty. Whoa, nice. Okay, that's right. Okay, so that one was correct, and this one is also correct now. The second one. Okay, so let's go to number 3. Okay, so you have z at the top, and then what's the next tier down? What variables are in the mid tier? Yeah, there's an r and a theta, right?
Theta.
Yeah, r and theta. Okay, and then the bottom tier, so you have r equals st, here you have theta equals the square root of s squared plus t squared to the s to the 6th plus t to the 6th. So that means you have s under t, right? Okay, so there's lots of tiers there, and I guess that theta could also be written as s to the 6th plus t to the 6th, all raised to the 1/2 power. And we're supposed to find partial of z with respect to s, so that's going all the way from z down to s with both those routes. And the partial of z with respect to t. So let's go with the partial of z with respect to s first. Okay, so what's the formula from that one going to be?
T set over TL times by TL over TS.
Yes.
Plus
And then
T theta.
you go down.
T theta over TS.
Yeah, so then you go down the other route too. Okay, so dz dr, that is, okay, that's just a constant when you do that. So it's just going to be e to the r. Oops. E to the r cosine theta. And then times dr ds. So that would be the partial with respect to s, which is just going to be t.
T.
And then this one, dz d theta, that's going to be minus e to the r sine theta times d theta ds. Here's theta. The partial with respect to s. So that's going to be, you're going to have a 1/2 come out, right? And it's going to be s to the 6th plus t to the 6th to the negative 1/2. And then you'll have a 6s come out, but that's going to be the 6 will reduce with the 1/2, so that'll be 3. S to the 5th. Okay, so all that. And then you have to, I guess we could factor an e to the r out. So this guy comes out because it's common to both terms. So e to the r, but then you put an st in for that. So it's e to the st comes out from there and there. And then you have t cosine t. No, cosine theta is cosine of that. Okay, then we have minus sine theta, which is, or times all this. So that's 3 s to the 5th sine of the square root of s to the 6th plus t to the 6th over this, which is the square root of s to the 6th plus t to the 6th. Whoa, that's crazy. Whoa, this is crazy. Okay, so that is indeed the answer right there, according to Webassign agrees with me. And so the next thing would be, you got to do the second part, of course, which is z dt. I'm not going to get into that. But let me point out right here that there's another way you can do these things. And well, let me just show you. Let me just show you on this one how another way that you could do it. You could do this. Whoa. Well, that's bad. What did I just do? Well, that's weird. I just erased everything. Oops. Oh, that's weird. How do I get that back now? Just a second. There we go. Okay. Okay, I gotta be careful. Okay, so let me show you how to do how you could another way you could do this. So right here, you have z equals e to the r cosine theta. You could also say that's e to the st, right? E to the st. So instead of having an r there, you could just write st. And then you have, instead of cosine theta, you could just write down cosine of the square root of, or in this case, since we're going to be taking the derivatives and stuff, I would write it as s to the 6 plus t to the 6 to the 1/2 power. Just write it like that. So write z like that. And then just take the partial of z with respect to t, like that. And then just work from here, okay? So it would be the product rule. So the partial of this with respect to t would be s e to the st times all that. And this one, just write it as s to the 6 plus t is the square root. We'll write the square root there. Okay, plus this e to the st times the derivative of this with respect to t. Okay, and then this one's going to give you negative sine of the square root of s to the 6 plus t to the 6. And then the derivative of the inside, they're going to have a 1/2, and you're going to have a t to the 6t to the 5th come out, right? So that's going to be 3t to the 5th comes out there. And then you're going to have this to the minus 1/2. So it's going to be all over the square root of s to the 6 plus t to the 6th. Like that. Okay. And so again, you could factor in e to the, this is multiplied, by the way. You could factor in e to the st out, and you end up with s cosine of the square root of s to the 6 plus t to the 6. And then you have minus 3 t to the 5th sine of the square root of s to the 6 plus t to the 6, all over the square root of s to the 6 plus t to the 6, like that. So that's interesting. It is pretty much the same as the other one, except so if you copy the other answer and then change here. So you change that t to an s and then this s to a t. Then those are the only differences right there. That's because they're kind of, because s times t is the same as t times s, and then this is the same as the other one. Okay. So that's another way you could do it. You could have done other problems that way too, but we're just showing the chain rule. Okay, so we come down to number 4. Suppose f is a differentiable function of x and y. G of u v equals this. Is a function of u plus e to the u plus sine v, e to the u plus cosine v. I use the table of values to calculate gu of 0, 0 and gv of 0, 0. Okay, so let's get things straight first. And we'll do that with a tree diagram. So what do we have at the top here? We have G, right? And then G is a function of what and what? This is really weird. Oh, dang, this is confusing. Okay, hold on. This is really confusing. I should have looked more at this. I thought this was something to be different than what I thought it was. So all this is kind of like our x, and all this is kind of like our y, because it says f is a differentiable function of x and y. So this is like our x, and this is like our y. Okay. So x is really e to the u plus sine phi, and y is really e to the u plus cosine phi. Okay. So f so you have f, and then that's a function of x and y, and then x and y are each functions of u and v. Okay, so that's one way you could look at that, but really we're after what these partial with respect to g are. Okay. So another way to look at it is the g is sort of on the same level, but then that's only a function of u and v, like that. Okay. So GU, that's with G sub U, that's like the partial of G with respect to U. Okay, and then, so that's really partial of F with respect to X, times partial of X with respect to U, plus the partial of F with respect to Y, times the partial of Y with respect to U. Okay, so that's how the chain rule is going to work in this situation. Okay, so partial of f with respect to x is, and then what happens is we can apply these 0 and 0 for u and v. And when u equals 0, then x, okay, so when u is 0 and v equals 0, what's x? And what's y? So if you plug a 0 in here for u and a 0 for v, what do you get? So plug a 0 in for u, and you plug in a 0 for v, then that's going to be 1, that's going to be 0, so just get 1. And then if you plug in here, if you plug in a 0 for u and a 0 for v, you get e to the 0 plus cosine 0, so y is going to be 2. Okay, so here, this piece, let me back up a little bit. Okay, so this piece is really fx of 1, 2. Okay, because when the u is, so yeah, because that's when x is 1, and because when u and v are 0, then x is 1 and y is 2. So that's going to be that one. And then dx du, this will be the partial of x with respect to u, evaluated at 0, 0. But here is x So this one, the partial of x respect to u, that's just going to be e to the u, right? So we have times e to the 0, okay, because u is 0, okay? And then this next piece right here, df dy, that's going to be f sub y evaluated at 1, 2. And then this one, dy du, so partial of that with respect to u is just going to be e to the u. So that's going to be e to the 0 as well. Okay, so here, fx of 1, 2 is 6, and that's 1. And then this one is 5, and that's 1. So it's going to be 11. So so gu, so g sub u of 0, 0 is 11. Okay. Now we're gonna go for gv of 0, 0. Okay, so that's going to be fx at 1, 2 times the partial of x with respect to v this time, plus fy of 1, 2 times the partial of y with respect to v. And this is going to be evaluated as 0, 0, and that's going to be evaluated as 0, 0. So this is, again, this is going to be 6. This piece right here, partial of x with respect to v, that's going to be cosine v, which if you put zeros in there, you get 1. Cosine 1, or cosine 0, I'm sorry, which is 1. And then this one is going to be 5 still. But here you have dy dv. Dy dv is, or the partial of y with respect to v is negative sine v. Okay, so this is going to be negative sine 0. So that's 0. So just going to get, so you're just going to get 6 for the second part. Okay, great. So let's go to number 5. P is u squared, the square root of u squared plus v squared plus w squared. Okay, so what do we have at, and then u is this, v is that, and w is that. Okay, so what do we have at the very top? What's the very top? The most dependent variable of all here. The way this is set up.
TP.
Yeah, it's just going to be p, right? Okay. So p is at the top, and then what are the intermediate variables?
There's gonna be U. Oh no. Yeah, U, V, and W.
Right, and then the bottom tier variables?
It's gonna be X and Y.
Yeah, there's x's and y's everywhere.
Are we still gonna use T too?
There's no t's here, so.
Oh.
So it just kind of depends on, you have to look at the variables and you know, these, so like last time the x's and y's were the intermediate tier, right? And the v's were actually, the u's and the v's was actually the bottom tier for the previous problem. But it just depends on how things are set up. So yeah, it's kind of weird. Okay, so this is the same as, so P is the same as u squared plus v squared plus w squared all to the 1/2, right? Here they're saying we're going to consider when x is 0 and y is 4. that's what they're after. Okay, so dp dx, which is the first one we're supposed to find. So it's the formula for that one. So you take all paths from P down to X. There's 3 different ways, right?
It's gonna be TB over TU and times by TU over TX plus
Yes.
TB over TV times by TV over DX plus
Yes.
TB over TW times by DW over DX.
Good. So dpdu, let's see here. That's going to be,
Half. Oh,
yes, there's going to be a half coming out.
that. So
So
2
and that's going to, yes,
and
2,
it's
there's
gonna
going to be
cancel
2u.
with the 2.
So you just get this, right?
Yeah.
So dpdu is just this piece here. So that's good. And then
Times it by
times du.
TU over
Yeah.
DX, which is just gonna be e to the power y.
Exactly, e to the y. Okay, so that's e to the
E to the
y.
y.
Okay, let's do this because these dpdv and dpdw is also going to give you
Just
this
v
square root in
over
the denominator. So just imagine that this is over in the center. Okay, we'll put it in the center next step. Okay, so that's going to happen every time, except this one is going to be a v coming out, right? Times something, and then the last one's going to be plus w times something. Okay, so dv dx, that's going to be,
It's just gonna be y e to the power of x.
great. And then dw dx right here.
It's gonna be e to the power xy.
Times y.
Y.
Because the derivative of this is just going to be,
Just
and the
y.
partial of this is, yeah, just y. Okay. Okay, great. So let's see here. Okay, so now we need to like get everything in terms of x's and y's. So u is x e to the y, so that's going to be x e to the 2y. Okay, and then v is y e to the x, so that's going to be
Y squared.
y squared e to the 2x, and then w is e to the xy, so that's going to be y e to the 2xy.
X to xy. Okay.
Okay, then down here we have u squared, which is going to be x squared e to the 2y, and then we're going to have plus this one, y squared e to the 2x, plus this one squared, which is e to the 2xy.
2x.
That's weird. Oh well. Okay, so then you set x equal to 4, and y, or I'm sorry, x equal to 0, y equal to 4. And what happens? Let's see here. We get that's 0.
0.
And then this is going to
That's
be,
gonna be 16
times e to the 0, which is 1. And then this one's going to be
just
4, right?
4.
Okay, good. I like that x is 0. I really appreciate that. Thank you, Webassign. Okay, so and then here that's going to be 0 as well, and then this is going to be wait a minute.
16.
Oh,
And
and that one,
it's gonna be 0. So 1.
1. Okay, so we have 20 over the square root of 17. That's weird. It's correct though. Okay, so that's the correct answer. And I'll tell you what, I'll let you guys do the next part on your own, okay? It'll be good for you. Yeah, that'll be good for you. But you can just follow these steps here. The denominator is going to be the same. And yeah, so I'll let you do that one on your own. Well, and that's it. Okay, that's all the exercises. I thought there was a story problem. Oh, well,
Oh,
I guess not. Anyways, we're supposed to also get into the next section, or like some good progress into the next section. I really thought the 14.5 wouldn't take so long, but unfortunately, these problems had a lot of work to do on those.
Wait, Taylor,
the
we're not
B
gonna do
homework
number 6?
What's that, Taylor?
Are we not going to do number 6 on the homework?
yeah, this is number 6.
Whoa, this is a number 6. How did that? That's weird. I don't see how. I don't know how I didn't write it down. Okay, so number 6, I guess. Okay, so you got number 6. So the length and width of a box change with time. Okay, so you have a box, and it has length and width, and so you know that the volume. Wait. Okay, so the volume. So the first question is about the volume, and you know the volume is the length times the width times the height, right? And it says that they're changing with time. The length and the width and the height. This is like a magic box. I don't know. Maybe it was found in some cave, ancient cave, and it's like this magic box that the length and width and the height are constantly changing. Ooh. Okay. So, anyways, at certain instances, the dimensions are 3, and so this is 3, and those are both 8 at a certain instant. But the length and width are increasing at a rate of 4 meters per second. Wait a minute, really? That's crazy. So dl dt is 4, and dw dt is also 4, and the height is decreasing. dh dt is -9. At that instant, find the rates at which the following quantities are changing. Whoa. Okay. So what you want, so basically here for the part A, the volume is length times width times height, right? So dv dt, okay, that's going to be the partial of v with respect to L times what? Times the derivative of L with respect to t, right? And then plus partial of v with respect to w times the derivative of w with respect to t. That's supposed to be a w there in the top. It might look like something else. And that's supposed to be a L there. dl. Okay. Plus the partial of v with respect to h times dh dt. Okay, so what's the partial of v with respect to L? Okay, there's the equation, right? It's L times W times H, right? Partial of v with respect to L. So you treat the W and H like a constant, right? So you basically have a constant times L, so the derivative is just WH, right? The partial of V with respect to W is LH, okay? And then dW dt. And then the partial of V with respect to H, that's just going to be LW, dH dt. Okay, now they say that L is 3 and also W and H are both 8 that instant of time. So that means you're going to put an 8 here for W and 8 in for H, and dL dt is 4. Okay, then an L and an H, so that's 3 and 8. And dW dt is 4. Okay, then you have L and W, so that's 3 and 8. But this one is -9, right? Okay, so you just add those together. So what is this? Whoa. Let me get my calculator. Okay, so 8 times 8 times 4 plus 3 times 8 times 4 minus 3 times 8 times 9. Anybody get an answer? I got 136. And Webassign agrees with me. Okay, part B is the surface area of the box. Whoa. So if you have a box, what's the surface area of that box? Okay, so let me think. You can kind of draw a picture of the box if we want. And so we have the length, the width, and the height. So the box is going to have 6 sides, right? And so you take all the combinations. There's 2HL. That's this front and the back from this perspective. And then from the sides, we got WH, right? So 2WH. And then the top and the bottom are going to be LW, right? Like that. Okay. So what's the derivative of area with respect to time? Well, it's going to be partial of A with respect to L times dL dt plus the partial of A with respect to W times dW dt plus the partial of area with respect to H times dH dt. Okay, so dA dt or dA dL, that's going to be 2H plus 2W, right? 2H plus 2W. And then dA dW, that's going to be, that's 0, and this is 2H. Wait. Plus 2L. And then dA dH is going to be 2L plus 2W right here. Okay, so you plug everything in. So H is 8 and W is also 8. So this is going to be 16 plus 6, that's going to be 32. And then dL dt is 4. Okay, this one is 2H is 16, 2L is 6, so that's 22. dWt is 4. And then here we have 2L, which is 6, plus 16, that's another 22. But that's multiplied by -9. Okay, so add those together.
18. I got 18.
You got 118?
No, just 18.
Whoa.
All right. Yeah, 18.
Okay, great. So 18. Nice. Excellent. And then what's the other one? The length of a diagonal. Oh, dear. So C is the length of a diagonal. So that goes from, say, here to here, and that corner to that corner. Whoa. Okay, so if you look at the back corner, dang, hold on. Okay, let's see. So if we go, maybe we could go across here, this diagonal here. So we want to, and then in this diagonal. So first of all, let's find this diagonal here, going from there to there. What's that length right there? If this is L and that's W, then the blue one is what?
Wouldn't that be the hypotenuse of those two?
Yep, it is.
You
The
just
hypotenuse.
take the square root of both of them. The sum of the square roots, which would be, what are our length? I don't know what our length is. The L squared plus W squared, yeah.
Okay, so that means that's the blue one. Okay, now the black one, it's going to be the square root of that squared plus that squared, right? The diagonal, we'll call that D. Capital D is going to be the square root of that squared plus H squared, right? Whoa, that's going to be just the square root of all three of them. That's weird. Really, that's what it is? Okay, so we want to know d dt. That looks weird, d dt. Okay, so I go through the same steps again. dA, no, not an A. dd, dl, and then dl dt, plus d w times dw dt, plus dd dh times dh dt. Okay, so that's the derivative of this with respect to L. Let's do that over here because we don't have a lot of space. So dd dl. So that's you're gonna get a square root of the sum of the three squares in the bottom, right? And in the numerator, you're gonna have just an L, right? Because you have a 1/2 come down, so reduces to minus a half, which is there. So you have 1/2, but then you have a 2L coming out, so that takes care of the 1/2, and it neutralizes the 1/2, and you just have an L, right? That's what that is. Okay, so when we plug in the L is 3, right? And then down here, we're gonna have L squared plus W squared plus H squared. So that's the square root of 9 plus 64 plus 64. Okay, so what the heck is that? 9 137.
Yeah.
Is that prime? Okay, so we have, this is 3 over the square root of 137. Whoa. And then dl dt is 4. So that's 4. Okay, then this one is going to, instead of being an L there, it's going to have a W, which is 8. So that's going to be 8 over the square root of 137 times dw dt, which is 4. And then this last one is going to be, instead of an, it's going to have an h in the numerator, which is h is 8. So that's 8 over the square root of 137. And times dh with negative 9. So it's going to be minus, and then there's a 9 there. Okay, so, what's that going to be if we add all those together? That's interesting. 12 plus 32 minus 72. So it's negative 28 over the square root of 137. Oh, round your out to decimal places? Oh, round to 2 decimal places. Okay, so negative 28 divided by,
I got negative 2.39.
okay, and let's see. So negative, so great, negative 2.39. Okay, you guys, does that work?